Just quickly, I'm going to go through motivation and the basic problem statement of what we're dealing with, and then introduce some basic terminology so that we can get to the main part, and that is the analysis, where I hope to share a few things with you, and then the conclusion. Now, first of all, email forensics is definitely practically relevant. There's the famous Enron case, if you're not familiar with it. A company, an oil company in America, went bankrupt, a lot of fraud. The main source of the information that the executives were prosecuted came from emails. There were well over 500,000 emails there. Then another famous one, Hillary Clinton. She was Secretary of State. She used her own email server for state as well as private emails. We know that the emails released that were related to state emails were over 30,000. But I think on the email server there were over 60,000, so she had to delete quite a lot of her personal emails. And then something closer to home, the Gupta emails that came from their server was Amar Bughani and Daily Maverick uncovered a lot of it in the media for us. The number of emails are unknown, but we know it's quite a lot. Well, I know it's quite a lot. I spoke to one of the investigators. But we don't have any numbers. Okay. So, what happens in the literature? In the literature, the proposals often to deal with large data sets and so on is to draw social graphs. Okay, and you've got a lot of emails, you draw these graphs, you take all the email addresses as nodes, and connections between two nodes indicates that there was email flow between them. Now, this particular graph that you see here is well in excess of 60,000 emails, 4,000 email addresses, and about 8,000 links. Why do you deal with a graph? Because if you can eliminate some of those email addresses, you eliminate a lot of the emails. Keyword search, we heard earlier, a lot of people are still doing their research, keyword search. It's true for emails. We want less false positive hits on emails we're not interested in. Okay, now the main problem that we face. The literature deals with drawing these social graphs, but it doesn't tell us how do we interpret this, how do we make this useful for an investigator. And hopefully in this presentation I'll give you some insights into what can be done with social graphs. Now first, before we get to that point, how would we approach something like this? Well, eliminate some of the emails that's not relevant to the investigation. Okay? So first we draw the graph, then we eliminate as many as possible nodes that can be at glance or any other information that we can use. Find possible structures, and hopefully these possible structures tells us a bit more about what these people are communicating about before we start searching for the content of the email. Because remember, the content of the email is the important part that's going to prove something in a court of law. In this case, I'm not taking these other things like spoofing and other type of email forensics that we're looking into. And then when you finish with that, you just proceed with the emails that's left. Typically, I think these will be iterative processes. I'm not an investigator myself, but I'm quite sure it will be an iterative process. So if there's a key takeaway I want you to take today from this talk, that social graphs are useful, but we have to combine them with other information, often external in investigation, to enrich that investigation. Okay, so quickly, some background information that you maybe know or do not know. Each node is an email address. There's a connection between them if there was email flow, right? One concept that we need to understand is the degree. If you look at that central one, marketing attacks, the degree there is 7 if we ignore the self loop. Okay, the degree of market research on the left-hand bottom is 1. Okay, because there's only one edge flowing from that. Okay, Another concept that we need to deal with is the concept of neighbors. So market research, if we take that as our reference node, it has a first neighbor doctoral students, okay? 2 hops away is marketing at Tux. Important to understand that this indicates to us that from market research to doctoral students, there were definitely email flows as well as doctoral students to marketing research. There might have been emails forwarded from market research via doctoral students to marketing, but not necessarily. So even though there's a connection, it doesn't mean that there was ever any information flow between them. So we're mainly going to deal today with first neighbors, but the second neighbors, of course, is away from the reference node is marketing, and the third neighbors, all those that could have potentially forwarded. Now, personal mailbox. I used my own personal mailbox simply because it's accessible and I don't need to get special ethical consent to use it. I give the consent. We draw this graph. Using Python, we extract the to from fields and then put it in a graph. We use a graph library, and then we use something like Citoscape to visualize. There's many options to visualize. The nice thing about Citoscape, you can interact with the thing. You can delete nodes. You can go crazy, just what you want to do. You recognize 3 distinct structures there, right? There's the unconnected set of structures, which comes as a surprise. I mean, it's my mailbox. I would expect everybody sent something to me. There's also the structured nodes. Nice petal-like flower ones, they're very easy to recognize. And then, of course, there's that cluttered area. And as you can see, that makes up the bulk. And that's where our main problem is going to come from. So let's quickly look at what happens in each of these structures. When we analyze and we look into those unconnected structures, they are mailing lists. Very nice. Mailing lists have this ability to hide who they're sending to, a good mailing list. Okay, that's what we expect, and that's why it's not connected to me. It doesn't include my name or my email address in there. Because they lose, they're very quick to recognize in the graphs, and we can, of course, always double check some of the emails just to make sure that's what's happening there. These is, I like to refer to as informal mailing lists. You all have friends who update you and copy all your other friends, and you're collecting email addresses. Hopefully nobody's selling those email addresses. You also see it in companies. One person that sends a lot of emails to other people. Interesting or important to recognize here, because that central person was sending to a lot of other people, and we never applied to that one, including myself. All these other people are unconnected. So you might potentially eliminate in an investigation those additional email addresses and not worry about them. However, as I said, our main problem is that central structured area, central cluttered area, sorry. Unfortunately, we found a way to get around that quite simply. We choose the, I just have a diagram of the central part, ignoring the rest so that we can illustrate this. You look for the highest degree node. In this case, it's my email address, of course, because most of them were there. And we delete that node and redraw the graph, and that's what comes out. All of a sudden, there's a lot more information, a lot more structure that's revealed. Of course, this graph you have to interpret with the knowledge that you deleted one node. You fall from about 8,000 connections to roughly 5,000, where we had 4,000 email addresses. So it shows to you a reduction in complexity. What's nice now is we've got a lot more single interaction email addresses. So if we know something from the investigation from the outside that we're looking on a one-to-one conversation, you could quickly zoom in on those. 2 addresses that interacted with me, doesn't matter, it can be 3, 4. In this particular data set, it was only 2. The mailing lists are still there, and you can see there's a lot more of these petal-like structures that come out that's now visible, but we still have that cluttered area to deal with. Okay, we're always going to end up with that. Another strategy that you can follow is you can try and identify specific communication groups. So now we are at the other end. We start somewhere in a structured area. In an investigation, we can say, okay, this comes from external information. So maybe we know that the information has got something to do with acquire. This happens to be one of acquire. The one there at the bottom is a chanticleer.coza. You look at the domain, you look at the name of this particular email address, and you deduce that that's maybe some sort of a list. You take the first neighbors, and that's what you get. These are the people they interact with. Again, let's use information external by just looking at a subset of emails here. In this case, famous conductor Richard Koch is known to be the choir master here. And we go and we select his first neighbors, and that's what we get. You take the union of the two of the two groupings of first neighbors with external information that you add, and this is actually the graph that you end up with. So, of course, it doesn't mean there are not emails in that set that is not relevant to the investigation, or it doesn't mean you can eliminate that whole group. It just gives us some structure to work from if we were looking at a subset of people to do searches on keyword searches. Again, let's look at if we have first neighbors and we try to identify group membership. In this case, we say there was information flow from one group to another. That's maybe the focus of the investigation. The ones in red are the main subject that's under investigation. And if you select the first neighbors, you get a grouping like this. This person happened to use two different email addresses to communicate in these groups, and this definitely was a communication group from these emails. Looking at domain information and the names there is typically at SABS, it's at ISO.org. You assume, okay, maybe it's got something to do with standardization, go read a few emails, okay, and indeed that's a standardization emailing group, people that emailed amongst each other. That same person happens to have, by name, the same name, but a different email address in this set. Okay, now again, select the first neighbors and you build up this group. If you build up this group, you again do the same thing. Those in greens indicated it's Stux. A lot of the others are Gmail. If you go read a few of those emails, you realize, but this is the lecturer, and you can guess who it is, that sends out emails to his students, and he copies a lot of them. Okay. Now let's take this time the intersection of those groups, and it reveals that there's one person that can potentially be information flow from the ISA group to the university group. So if you were investigating something like that, it helps you to find people who are in common if you start building up groups and taking intersections. This is a simple example that can get complex. If I've done quite a few of them on this data set. Interesting thing to notice about this, though. In my email box, sit with a subset of emails that belongs to this main subject. All right? So if the main subject was under investigation and we could show that he communicates to me, we could potentially ask for a warrant of emails related to that subject's communication in my email box, and we can draw them from first neighbors. I actually sit with potential emails that he might have deleted in his box before the investigation started. Of course, it's useful in graphs always to simplify something. Here I show something very simple. When we've got an interaction like that, we can group it as a communication group of ISA, a communication group of the university. Okay, so let's conclude. The general strategy is to work with nodes which references associated emails. That's an important thing. If I have a node, I can immediately draw the exact emails that's associated with the communication to and from that node, which is a lot less than dealing with the whole mailbox. Eliminate nodes that are not relevant to the investigation. Then use strategies to make sense of the graph structures. Typically, use domain information, use first neighbors for the groupings, external information that can come into the investigation. We never mention this in the literature. Identification of communication groups, I think that was already discussed. And then when all is done, we focus only on the content of emails of the nodes that are left, and it's a lot less emails to deal with. Future research, we need to show that this actually generalizes to other data sets. I've already started on that, and initially it does seem like it. We use the Enron data set. It definitely does seem to generalize. Automation of some of the actions, of course, typically something one can do is identify communication groups automatically. Maybe not that easy, but it might be possible. Identification of mailing lists, I think, would not be so difficult. The removal of cluttering, actually quite easy, because you look for the high degree nodes and you start deleting it and producing subgraphs from that. And then linked to external data, domain data. Typically, if you have a list that you maintain, and a lot of the investigators do this, they maintain lists from previous investigations, and they can quickly eliminate, based on previous investigations, some of the nodes. Enriching graphs beyond the standard nodes that's in the literature, I think that's the future that this is going to be. You reduce the clutter, and then you start adding other information than just purely the email flow and the addresses. Okay, and again, just the key takeaway. These things are useful, but we have to combine them with other sources of data. Okay, any questions? I have 60,000. Yeah.
Anyway, thank you very much.
Okay. Thank you.
He also said at the beginning of his presentation that, you know, the presentations here at ISA is quite diverse. And I think it's the best compliment you could have made for ISA. Cybersecurity has moved, especially so in the past 5 years, pretty much in the direction of multidisciplinary, transdisciplinary, and interdisciplinary. And I think it's extremely important, and personally, just based on my exposure to security, I started off with computer security in the beginning of 1980s, and you know, that only had to do with big mainframe computers. And then with the introduction of the PC in the beginning 1980s, moving into network security and internet security. And then it moved onto you know, various forms up to the current cybersecurity. And you know, every time I'm re-establishing myself and say, yeah, I'm also now a cybersecurity expert. But having said that, cybersecurity by all means is you know, a multi-interdisciplinary field. And I feel that adds to the complexity of really coming up with solutions, because you really need to go out and collaborate across those subject disciplines. It's not only an area for computer science or IT, but very much so from a social behavioral point of view, especially with generative AI now. I think you know, that's a very important, valid comment, and thank you for that.